The Cherry 3D printer is a printer that is designed to be both cheap and easy to assemble. It runs on some stepper motors that don't cost very much. In fact, they only cost about a quarter of what a NEMA 17 motor costs. And the entire design is very, very simple. It requires only a few printed parts. This tutorial is going to walk you through how to assemble one. We're going to try and improve on the original design, increase the build volume, and then at the end of this, the goal is to have a working 3D printer that I can then turn around, print off another set of parts with it, and then forward them on to one of you guys, one of my subscribers, along with some extra motors and stuff that I've accumulated so that you've got a good head start on building your own. And then the ideal scenario after that would be for you to put yours together, print off some parts, and then pay it forward to somebody else in the community who wants to get one of these up and running. So let's switch to the overhead view. We'll get started with the tutorial now, and then you can like, comment, and subscribe for the future videos that are going to finish this off. It's going to take between 3 and 5 episodes to get it done. And at the end, I'll let you guys know how you can enter to win a set of the printed parts, plus, as I'm saying, some of the extras, motors, and parts that I accumulated when I ordered them from China. So let's switch to the overhead view, do a quick walkthrough of the parts, and then we'll get started. Now, quickly before I forget, the bill of material is going to be listed underneath here, so you can use the links provided to go and purchase the same stuff that I did. If any of the items aren't available since I did order these a couple of months ago, let me know and I can find you a suitable replacement if you're unable to do so yourself. So let's just do a quick run through of the parts we're going to need. So first of all, we're going to need a hot end. This is an E3D V6 clone. This is not the all-metal version. You can substitute the all-metal version for it, but since all we're doing is printing PLA with it, it's not really necessary. And I will also say that when it comes to the clones, the ones with the Teflon tube do seem to work a little bit better than the all-metal ones. The all-metal ones do need a little bit of cleanup to get successful prints, at least some of the time. From there, we're also going to need a 12-volt power supply. This is a 12-volt 10-amp power supply that's usually used for powering lights. This will be plenty since we're not putting in a heated bed. 10 amps will be more than enough to power the system, and as an added bonus, you won't have to deal with wiring mains power with this because you can just clip the end off and only deal with the 12 volts. You're going to need a standard ramps board with your stepper motors. The two most common sets of stepper motors should work with this absolutely no problem, so I ordered this as a kit with the ramps plus the Arduino plus the 4 stepper motors and the heat sinks, and that was the cheapest way to do it at the time. You guys can of course source your own version if you wish. You're going to need your 8mm rods, your smooth rods. The way I've set this up is that you order 3 smooth rods and then use a hacksaw or a rotary tool or whatever to cut them into the pieces that you need. It's cheaper that way than trying to order custom lengths. Then you're going to need your end stops. These are 3 mechanical end stops, so just the regular micro switch on them. You can potentially go with an optical one as well. That's up to you guys, but that was the cheapest way to go. You're going to need some regular bearings and some linear bearings, both of which the models will be provided underneath. You're going to need some pulleys. These are just the standard GT2 pulleys with a GT2 belt. You're only going to need probably about 1 meter to 2 meters if you want to be safe worth of the material, so you should be able to find a kit pretty cheap and, again, provided in the list below. You're going to need some motors. Now, these motors are the 2.8 BYJ 48 motors, and when you're ordering them, be aware that there are 2 versions. I'm hoping this will focus in. This is the 12-volt version of the motor, so I'm hoping if I just do that... No, doesn't feel like focusing. There we go. So you can see it says 12 volts DC. The first set of motors I ordered wasn't actually the correct ones. They were a 5 volt version of the motor, which is the one here. So although technically you can... Here. Although you technically can get the 5 volt version to work with this, the 12 volt ones will be way better in the long run for what you're trying to do. And then, of course, you're going to need the printed parts. So you're going to need the parts for the X, Y, and Z axis. And on top of that, you're going to need some screws. I picked up these M4 screws, which are what we're going to use to secure the motors as well as create the enhanced pulley system, which kind of looks like this. So that the belt, much like on the old PrinterBot Simple Metal, sort of goes wound around it. So I picked up these ones here at... Home Depot, I believe, and they're snap away, so you can get the length you need of it just by breaking off the piece that you don't. And then on top of that, you're going to need some M3s and some, you're also going to need M5 threaded rods for the Z-axis. They haven't shown up yet. But again, they're listed below, so you can order the same ones that I did, and you'll have to use a hacksaw as well on those to cut them in half. Unfortunately, the only supplier I could find does send out 2 of those. You can't get them individually, so you're going to end up with some extra, but on the bright side, if something goes wrong, you're going to have that to fix it. In addition, you will want to secure a 1x4 that is at least, say, 2 feet long, so you'll be able to cut into the pieces you need, and then you're going to need some sort of wooden plate to attach it to. The original design called for it to be made out of MDF. I'm going with project wood. It's going to be hopefully a little more secure, and you can stain it and secure it if you want to seal it. Alrighty, let's move on to the modification of the motors now that we've gone through the parts, and we'll go from there. And here we have our stepper motor, and the first order of business is going to be to get this blue cap off. Now you're going to want to be very, very careful because the circuit board is directly underneath it, so you're going to want to be nice and gentle. It seems to work okay if you pry from the one side, but you may end up breaking the tabs, and we do hopefully want to reuse this cover to protect the circuit board once we're done. By pressing on the tabs, we can work the blue piece loose, and it will slide right up the wires. Some persistence may be required to get this out. With the blue cover off, now we can take our first look at the circuit board. Now this is a unipolar motor, and we're going to want to try and make it bipolar, and we do that by breaking the link basically between the 2 coils of the motor, which is this trace right here. So the first thing we'll do is show you how you can test the connectivity using a multimeter. So we pull our multimeter out here. And you can see by touching the leads together, when it's set to test for ground, it gives you the signal. So if we go ahead and touch it to the 2 contacts on the motor now, you can see there is indeed connectivity between these 2 points right here, and our goal is to break that connectivity. With an X-Acto knife or another sharp implement, we're going to very carefully cut across this trace. You want to make sure you don't damage any of the other traces, because doing that would basically ruin the motor. So you're just going to go back and forth. Now, if you were to nick one of the other traces, you could technically run another piece of wire between the 2 points to reconnect it, but it really depends on which trace you were to break and how badly you damaged it. So we just wear our way through here, and with that cut out, we can go ahead and hook it back up to the multimeter, again, testing to make sure that connectivity between the points works, and we see that there is, in fact, no more connectivity between those 2 points. So we've just converted this motor from unipolar to bipolar, which is what we need to make this 3D printer work. Since we no longer need that red wire, since it's not connected to anything, we can now desolder it by heating up this point here and then simply pulling the wire free, or we can simply cut it with a pair of flush cutters, as long as it's cut short enough that it can't make contact with anything else. And with that, we can then simply pull that red wire out of the housing, and we will be ready to put the blue piece back into the blue protector back into place. Luckily, since I'm editing this video, I can make it so you don't see how many times I failed to put this on before I finally got the piece clipped in. Suffice it to say, it doesn't always go easy, and the piece isn't guaranteed necessity, but it is good to have it back into place to protect that circuit board. Next, we're going to want to remove that red wire. You can simply push down on the metal tab on the connector, and if you push it in firmly enough, the red wire will come right out, and you can just toss it aside. Finally, we're going to want to switch these 2 middle pins around so that they're properly set up to be connected to the Arduino. So, much like with the red wire, we're going to push down on the metal tabs to get them to slide out from the connector. Now, the thing to be careful with here is that you can overextend or overbend the tabs, in which case they may not want to lock back into place afterwards. So you're going to want to be relatively gentle, and if you do accidentally bend them a little too far, it is possible to bend them back, but you do fatigue the metal every time you do it, so you want to do this as little as possible. So we free one, and then we just need to pop the other, and then we're just going to bend those tabs back into place, and we will relocate them so that they are properly oriented again. So you can see here, the metal tab, ever so slight, you can just use your X-Acto knife and just pry it up just a little bit. With both pins bent back into place, we're just going to slide them back into the connector, and we now have orange and pink together and yellow and blue together, which will allow us to use this as a bidirectional motor when connected to our ramps board. And just like that, we are done, and this connector will be reusable for the ramps board as the spacing between the pins is the same. Now, for one of the motors, we are going to have to add an extension to it in order to be able to make it connect, because these wires aren't long enough for all axes. Next, let's modify our power supply to be able to work with our ramps board. So the first thing we're going to want to do is get rid of the connector at the end. We just need the exposed wire. So take your flush cutters and go ahead and nip off the tip. From there, you're going to want to remove some of the sheathing. Now, you can use your flush cutters, or you can use your wire strippers, whatever you have on hand and whatever you're comfortable with. Now, luckily, this wire here has both positive and negative individually separated and individually insulated, so we'll just take a little bit off the tip of each of those. Now, red should be positive and black should be negative, but just to be safe, we're probably going to want to connect this to the multimeter to make sure. So when connecting red to red and black to black, we get an output of 12.3 volts, and that is proper orientation. If we then were to reverse them, however, so that we put red to black and black to red, you will see that it reads negative 12 volts because we've got it reversed. So that's how you determine which way the polarity should be connected. Our next step should be to get our ramps board populated and ready to power. So the first thing we're going to want to do is put all the jumpers that came with it into place. You'll find that there's 3 sets of pins in between each of the headers for the stepper motor drivers, so we're just going to populate all of those with jumpers. When it's time to place your stepper motor drivers, you're going to want to make sure that this potentiometer is pointed away from the power outputs on the ramps board. You'll simply position them over the pins. If any of the pins on the stepper motor drivers are bent, you're going to want to gently bend them back into place. Again, you don't want to overstress the metal because it will fatigue and break if you have to move it too many times. And finally, we place the stepper motor driver for the extruder, and we now have our XYZ and extruder stepper motors populated and ready to go. As a final step, make sure to place the heat sinks on top of the processors. These probably won't be heating up a lot with the amount of current we're dealing with, but it's better to be safe than sorry. And now we can move on to powering up and flashing our board. To power our Arduino, we're going to want to go ahead and connect our modified power supply to it. Now, as you can see here, the negative terminal is on top and the positive terminal is the second terminal. So we can remove the quick disconnect connector and then use our flathead screwdriver to unscrew the terminals to allow us to slide our cables in. Feed the black wire into the top terminal and screw it down to clamp it into place. You're going to make sure this is nice and firm. You do not want this coming out once everything's connected. And then we will push the red wire into place into the second terminal position and likewise tighten it down into place. Just like this. And just like that, that is now ready to provide 12 volts to our ramps board. Go ahead and reconnect it onto the board. And we're all set. All we need to do is put some firmware on it, and we should be good to go. Okay, so the first thing to know is if you don't already have the Arduino IDE software installed, which is the software you use to program an Arduino, and in this case our ramp setup, you're going to need to install that. So if you search Arduino IDE in Google, or you use the link below, you can go to the Arduino software site. And from here, you're going to want to download the full-blown IDE. You can get the Windows installer if you're on Windows, Mac if you're on Mac. You can make a donation if you want, or you can just click just download, and it'll start to download down here. I already have it installed, so we're not going to bother with that, but basically it's a simple installation. You just next. You can change the install location, that type of stuff. That's all up to you. The next thing you need is the Marlin firmware. So if you search Marlin firmware, or again use the link provided in the description below, you'll go and get the latest version of the Marlin firmware. And from here you can go clone or download, and you're going to want to download the zip file of the latest version of Marlin. You'll get a zip file down here, which you'll want to extract to a location where you can easily find it. I usually just drop mine to the desktop because it's the easiest to track down, but you may want to put it somewhere where you can hold on to it for future reference. So from there, you're going to launch the Arduino IDE, and you're going to open the Marlin file that you just snagged, and you're going to get all these files across here. The only one we're really worried about is the configuration.h, because we need to change some settings in here to make it work with our setup. The first thing we'll want to do is make sure that the motherboard section has the define motherboard RAMs 14 EFB provided here. The next thing we're going to want to do is provide the default steps per unit and the default max feed rate. So starting off here, and there'll be some adjustments made later on, we'll have to reflash this several times, but just for getting the motors up and running to test them, you're going to provide a value of for the X and Y of 655.36, 655.36, because that should be the number that'll get us within range for the GT2 belts attached to those motors. And then the maximum feed rate, you're going to be able to play with this to try and eke out the maximum amount of performance, but I find 15 works as a safe number right off the bat. If your motors aren't spinning, but it sounds like they're trying, you can lower this until they do work. But 15 seemed to work with the motors that I've played with. Finally, at least with the end stops I'm using, we're going to want to invert the X, Y, and Z min-end stops. Just like that. And then with the Arduino connected, we can then simply click upload to send it across. You'll want to make sure that the board is selected here as your Arduino Genuine Mega or Mega 2560, which should automatically select the Mega 2560 processor, and you're going to want to make sure that it's on the right COM port. If you're programming this off a laptop or a new computer, chances are the only COM port that's going to be listed is the one that your Arduino is connected to, so that shouldn't be a problem. So then you can go ahead and click upload. Well, that's flashing. The software will need to connect our 3D printer to our computer as Repetier host, so we'll go ahead and snag that now. So again, you can just Google Repetier, go to the download link. Same type of stuff. You don't have to feel obligated to donate, but it is important to know that a lot of the software is being developed for free, so it doesn't hurt to donate and to contribute to the cause. If you're going to do it without a donation, you click download without donation. And then you select your operating system, in this case, Windows. Once again, the download will start down here. Once you're done uploading, then you should be able to switch to Repetier host, which is here. Click connect, and it should connect to it and recognize it as being a 3D printer. From there, if you've got your 12-volt power connected and a motor connected, you can now control one of the motors, like this. So moving right, left. And I do recommend going through this and testing each of the motors that you modified. It's easier to check them out now and then replace one if you've broken it by accident than it is once everything's put together and screwed into place. And that will do it for part 1. Next week we'll get into assembling the frame and getting the parts positioned, and we should be able to get into assembling at least one of the axes. One of the axes. Anyways, if you like this video, thumbs up. If you want to continue along, then I'd love it if you subscribed, and don't forget to click the bell so you get notified as soon as I put out the additional parts. If you need clarification on anything, toss it in the comments below. I will do my best to respond as quickly as possible. If you have any suggestions about stuff you'd like to see me do with the build, then let me know. And until next time, stay creative.